So we're going to do some factory system stuff with the sim class here. Normally we would do this as a group. We would do one, maybe two different factories. And basically what this is, it's a culminating project that handshakes different machines together, basically puts all the skills together that you've learned this year into one big project. So we obviously can't do this because we're remote, but I can still have you work on it a little bit and leave it open-ended for you. Um, so we have something to do here. So basically what we're going to do is week one here is just planning stages. So I want you to generate, first thing I want you to do is generate 5 ideas for products that can be manufactured using a model of a flexible manufacturing system. I'll talk about that in a second. So right here, everyone's going to get a copy of this document here. Just edit it and write in your 5 product ideas. They can be something very simple, like a box that's a piece of wood that's put into the machine and carved out a box, or something that's carved, the Spartan logo or something into it, and then another machine, removes it from the bench mill or the laser cutter or something like this. A lot of groups want to do something with food. Oh, I want to make this thing that puts the toppings on the pizza or makes a s'mores, puts all the pieces together and then toasts them, and that's fine. For what we're doing right now, that's cool. In reality, I would not let you do anything with food because we don't want to get food all over all this equipment and all up in our classroom and stuff. So food is okay for this. So if you're going to do some sort of manufacturing system where you're going to place food items, great, plan it away. Okay, a flexible manufacturing system this is an example of one right here. Basically what it is it's using several different types of machinery, all computer controlled though, to create a product. All right, so if you take a look here, we have a track with 2 AGVs on it. We have 3 CNC machines, those are up at the top. We have some raw material storage, and basically what would happen is these AGVs would pick up the material from the raw material storage. This is a very crude drawing. There's there's no robotic arms stimulated in here. There's no removal of anything happening in here. It's very difficult to understand how the parts go from the storage um, to the AGVs, and then from the AGVs to the CNC machines. But that's where the robotic arms and stuff we played with would come into to effect here. So basically what happens is AGV 1, for example, will pick up raw material and then deliver it to one of the CNC machines, probably CNC 1. It would go in, the machine would do its thing, it would come back out and go on to the AGV. The AGV would move to CNC 2. It would do a different process, maybe with a different tool, or maybe with a different finish or something on it. Maybe one's a lathe and 2 is a mill and 3 is a CNC something else, maybe a laser etcher or something like this. So it would go and make its stop at the CNC machines, and then it would travel around to the load unload station and move on down the factory line, while AGV2 was right behind it picking up parts and doing the same exact thing. So the purpose of this is a fully autonomous system here, so that when the AGV gets to the raw material storage, it gives it a signal, and an arm or something allows the material to move from the storage to the AGV. It will then know that the material has been placed on top of it with a sensor and move to its next station. So this is an example of a flexible manufacturing system. And we say it's flexible because we can change all of these things. We can move them around. So what I want you to do is plan 3 FMSs, flexible manufacturing systems, to create one of your products. Sketch out the layout of where you would place your factory components. So very, very similar to this. Okay, so this would be like, oh, we're going to put toppings on a donut. We're going to get the donut. We're going to put, first this is going to be the frosting machine. And then we're going to move over here to the sprinkle machine. And we're going to move over here and put powdered sugar on it. Okay, or whatever. Please use at least 2 of the following in your brainstorming. We did a lot of stuff with the DoBots. We did some stuff with VEX, with the AGVs and other VEX things that you may have done in the past, marble sorters and so forth. You can certainly use the bench mill. You can certainly use the scorebot arms. The Dubot arms have different end effectors on them. So you could suction cup something, you could gripper something, you could write on it with a pen. That would be considered not an arm for transferring information or transferring product. It could be like, the CNC2 here might be a Dubot with a pen. And you put your product underneath there and the Dubot writes, something on it with a pen. And that would change it from a robotic arm into a CNC machine. So we have the capability of doing all of those. Dubot arms also have um, laser end effectors, so you could laser etch something in there with a Dubot arm. So sketch your ideas here. I just want 3 of these. Sketch them on paper, take a picture, put them in the doc, and we're good. And then we'll start talking about next week. We'll talk about process flow and how to actually plan this out as if we were going to do it. So let me know if you have any questions, and good luck.